session, I am going through section 10.2, which is on parabolas. And we're going to be looking at parabolas in a different way than we've looked at them in algebra. So 10.2 covers how to recognize a conic as the intersection of a plane and a double napped cone, write equations of parabolas in standard form, and use the relative property of parabolas to write equations of tangent lines. Since our assignment focuses on parabolas in standard form, that's what this session is going to focus on. So let's start with just conics. So conics are also called conic sections, and that's because you're slicing through a cone or a double cone. The book refers to a double-napped cone, but it's basically two cones that are with their tips touching. And if you slice through it at different angles, you get different conics. So these are the four conic sections you have. You've got a circle, ellipse, point, you can get a line. Those are not really considered conics because they're not really, you can get those algebraically as well. There's not really anything interesting about it. So the parabola. So we've seen parabolas in college algebra, and it is defined as the set of all points in a plane that are equidistant from a fixed. So the distance from the from some line, it's going to be the same distance no matter what. Let's see, the equidistance from a fixed line, the directrix. So the directrix is basically parallel to the way that it opens up. So if it's opening up, it's going to be underneath it. It's sort of parallel if you were looking at it. And then the fixed point is the focus. So the focus is not actually on the line. It's sort of a point where your parabola opens up. And the vertex then is the midpoint between the focus and the directrix. So it's halfway between those two. And in college algebra, we knew how to find the vertex of a parabola, but we never talked about these other properties. And then we've got the axis of the parabola. So that is going through the focus and the vertex. So the directrix is always perpendicular to the axis. And then if you're looking at any point on the parabola, it has the same distance from the focus as it does from the directrix. So that's what it means by equidistance. There's a lot of things to pack here, or to unpack, lots of vocabulary. Very long sentence, but this picture kind of does a better job than the definition here. So standard form of parabola. Back in algebra, we learned that it's ax squared plus bx plus c. Once you get to pre-calculus, standard form actually looks a little different. It looks similar to vertex form of a parabola. It's not exactly the same. It's not solved for y. It's not solved for x. So you can see how it's written here. We use h comma k as the vertex. And we have two different types of parabolas. We have ones that open up or down, which are vertical parabolas. Those are the parabolas you saw in algebra. And then there are also horizontal parabolas where they open left or open right. And those are not functions, which is why they weren't looked at in algebra, because college algebra is the study of functions. So there's two different equations, and they're very similar. The difference is just which part is squared. So for a parabola that opens up or down, it's the x part that's squared. And if it opens left or right, it's the y part that is squared. And so we've got these equations here. And what's key is not only to know the equations, but to also know the directrix and how to get the directrix. So the formulas for the directrix are right here. Now, if your vertex is at the origin, then it just boils down to x squared equals 4py, or y squared equals 4px. So these figures, it says, see the figures below. I actually have those on another slide. So this is the most useful part. And I'm sorry if you hear my dog barking. She's not happy that she's alone. So let's look at the vertical ones. Those are what we saw in college algebra. So you've got your vertex, h comma k, and then the focus is inside wherever it opens up, whether it opens up or opens down. the distance between the focus and the vertex is the value p. So in the equation that we have for a parabola, we need to find p. So that's just the difference between the focus and the vertex. And then you have the directrix, which is the vertex, and then to the directrix, that's also a distance of p. So the distance from the directrix to the focus is 2p. The axis then goes through the vertex, and it's where the axis of symmetry is. So in a vertical, it's going to be x equals h, because it reflects across a vertical axis. When we move to horizontal parabolas, our axis of symmetry is now going to be y equals, because we're reflecting up or down, we're reflecting across the x-axis. The definition for p is still the same. So p is still the distance between the vertex and the focus, and it's also the distance from the directrix to the vertex. So the equations are all very similar. You just have to watch at where y and x are switched and where h and k are. And then what the form of the equation is. But what I usually do is I draw a picture and then I go back to this and I look so I can determine, my values and what it's going to look like. So the first example here is getting standard form from the vertex and the focus. So if you're given the vertex and you're given the focus, I'm going to have to, okay, I'm going to be right back. My dog is very unhappy. I guess I'm going to have to put her in my lap. I'll be right back. Okay, I am back. She is now in my lap. Hopefully she will behave. Last time I had her on my lap while I was trying to do a live session, she threw up on me. So I'm really hoping that she doesn't do that this time, because that will be no fun. Okay, so we're going to find the equation of a parabola from the vertex and the focus. In order to do this, you need to have at least the vertex. You need to have some information related to the vertex. Or you could, if you have the focus and the directrix, you could probably figure it out, but you need two pieces of information, basically. So we're given that the vertex is 1, -8, and then the focus is 3, -8. So I always start by drawing a picture, because that helps me decide or figure out whether this is going to be a horizontal or a vertical parabola. So I'm going to just draw my axis. And then I have 1 and 3 and -8. So my vertex is right there. I'm going to just label it V for vertex. And the focus is there. Now, our focus is always on the inside of our curve. So that means my curve needs to surround the focus. So the parabola here is going to surround that focus. And so this gives us a horizontal parabola. So that means I need to use the equation for horizontal parabola, and it's opening to the right. And whether it opens left or right, it will work itself out when you're solving. So the important part is just knowing where if it's horizontal or vertical. So the equation for a horizontal parabola is y minus k squared equals 4p times x minus h. So we know h and k because that's the vertex. So the h is always the x value of the vertex, the k is always the y value of the vertex. So I can plug those in immediately. So I've got y minus, and then I'm going to change colors here just so it's clear. So the y value of the vertex is -8, so that's actually going to turn into +8. So you're subtracting a negative. Squared equals 4 times p, and then we have x minus, and then your x value of the vertex is 1, so it's going to be x minus 1 and then I close my parenthesis. Now I need a second piece of information in order to figure out P. P is the distance between the vertex and the focus. So that means this distance here is equal to P, and that is equal to 2. The distance between 1 and 3 is 2. So that means P is equal to 2. So I can replace P in my equation with 2. So I have y plus 8 quantity squared equals 4. And then I'm going to change colors here, times 2. And then I have x minus 1. Now we want this in standard form. So the only thing I need to do with standard form is do the 4 times 2. So I don't have to solve for y or anything like that. So I have y plus 8 quantity squared equals 8 times x minus 1. And then that's our standard form given the vertex and the focus. And I gave myself an extra slide just in case I needed it, but I didn't need it there. Example 2 here. We're going to find the standard form of the equation of the parabola given that the vertex is 1, 2. And in this case, we have the directrix, which is y equals -1. So I'm going to again draw a picture. So I can draw my vertex. I'm going to label that V. And then I'm going to draw my directrix. So that is at -1. And so it's y equals, so that is a horizontal line. So the directrix is always perpendicular to the axis of symmetry, and so that means that the axis of symmetry would be going perpendicular here through V, which means I need either open up or open down. And I know that I open up because it's always in the opposite direction of the directrix. So this gives me a picture, and this is going to be a vertical parabola. So our equation for a vertical parabola is going to be x minus h quantity squared plus 4 times p times y minus k. So I need to plug in h and k. That comes from my vertex. So I have x minus, and then the x value of the vertex is 1, so that's going to be x minus 1 quantity squared equals 4 times p, and then y minus k. And k is the y value of the vertex, so that is 2. So that's y minus k, y minus 2, and then close parenthesis. Next, I need to find out p. So p is the distance from the vertex to the focus, but it's also the distance from the vertex to the directrix. So the vertex y value is at 2, the directrix is at -1, so that difference is 3. So there are 3 units between those. So p is equal to 3. So I'm going to plug that in. I have x minus 1 squared equals 4 times 3 times y minus 2. So I'm going to multiply 4 times 3, so that gives me x minus 1 squared equals 12 times y minus 2. Now this is our standard form. We don't have to solve for y. We can just leave it like that. And so now we have the standard form of the equation with this parabola based off of the vertex and then the directrix. So we've gotten the vertex and the focus, the vertex and the directrix. Next, we're going to look at vertex and a point. Because generally, you're always going to be given the vertex when you're looking at parabolas. You are not going to be given like the focus and the directrix, though you could figure it out from there. So example 3, we have vertex and a point. So we're looking for a standard form of an equation of the parabola with a vertex of -1, 6. It's horizontal, so this is telling us which direction, and we need to know that because the only other way to figure out whether it's a vertical or horizontal is based off of the focus and the directrix. And if you're not given those two values, you can't determine, you don't know whether it's vertical or horizontal. So they have to tell us. And then it passes through the point -9, 2. So I'm going to draw my picture and then label my vertex. So that is at -1, 6. And then it goes through -9, and this is not to scale, this is just so I have an idea of how to draw it. So it goes through -9, 2. It's horizontal, so to connect those and knowing that the vertex has to be kind of the bottom of it, that means I have to open left in order to get through there. So we're going to go to our equation for a horizontal parabola. So that's going to be y minus k squared equals 4 times p times x minus h. So I'm given the vertex, so I can plug in my h and my k. So y minus k is the y value of the vertex, so that's going to be 6. Close parenthesis equals 4 times p, then x minus h, and h is the x value of the vertex, which is -1, so that's going to turn into x plus 1 because we're subtracting a negative. Now I need to find p. I can't find p unless I know the focus or I know the directrix, and I don't have either of those values. So what I need to do is actually plug in my second point so I can solve for p. So I'm going to be plugging in -9 and 2. So let me go back to my black. So for y, I'm going to plug in the y value of my second point. So that's going to be 2. So this is going to be 2 minus 6 quantity squared equals 4 times p. And then I'm going to plug in for x, -9. So it's going to be -9 plus 1. So now I need to simplify this. So first I'm going to do the 2 minus 6, so that's -4 squared equals 4 times p. Then -9 plus 1 is -8. -4 squared is 16. 4 times -8 is -32. So I have 16 equals -32p. I'm going to move on to the next slide just so I don't have to smush this in. So I have 16 equals -32p. And I need to solve for p, so I'm going to divide both sides by -32. So 16 divided by -32 is 0.5, so we can use 1/2. This is going to give us a -1/2 equals p. So now that I have p, I have to plug it back into the equation that I had with the x and the y. So I need to plug it back into this equation so I can simplify. So I have y minus 6 quantity squared equals 4 times p, so p is -1/2, times x plus 1. And now all I need to do is multiply 4 times -1/2. So I have y minus 6 squared equals -2 times x plus 1. Now I have the equation for the parabola in standard form. So that is basically it for finding the equation for parabolas. This covers pretty much everything that you need to know for the assignment. And I think, yeah, that covers everything you need to know. So thank you very much for joining me. If you are curious about my dog, this is my dog. She is deaf and blind and gets stuck in corners, and I think that's why she was unhappy. So her name's Cupcake. There she is. She doesn't know what's going on. All right. So if you guys have questions on parabolas, let me know. You have my contact information, and I will talk to you guys later. Bye.